All right. So, hi everyone. This is Vijay Pandey, and in this particular session, I'm going to discuss about the basic ACI questions in which I have posted in the LinkedIn, and many of these uh, folks has been requested like they like to know the answer of these questions. So, to be honest, I cannot guarantee the answer, exact answer, which is relevant to these questions, but because each and every individual will have their own way of version of the answer, right? So I'm going to give my version of the answer for each and every question which I have pasted here. Okay. So first question we have here, like, just give me a second. Okay, so first question we have, what are the two modes operation in the which Nexus series can be configured, right? So first is NXOX, second is ACI mode. So Nexus 9K will have two uh, OS mode, or configuration rather mode, where you can either you can run on the plain NXOX mode or second is ACI mode. When you convert this Nexus NXOX mode to ACI mode, you have to install the ACI image in the Nexus, and if you're running to the NXOX mode, and you have to install the NXOX image in this particular model. Okay, what is the second question is, what is the ACI leaf and spine architecture? So we have two tier architecture. We call it leaf and spine architecture. So how two-tier works? So we have leaf, we have spine. Okay, and leaf directly connect to spine. Leaf cannot connect here, or spine cannot be connected. Okay, that's a limitation, or that's how the ACI designed. Okay, and leaf and APIC, which is the policy controller, will always connect to leaf switches. Leaf APIC cannot directly connect to the spine switch. That is also limitation. This is the architecture of the leaf and spine. The third question is, in ACI mode, can we connect one leaf directly to another spine to spine, or can we connect leaf to? Again, this is the same question. So answer is no. This is not possible. Leaf to leaf you cannot connect, or spine to spine you cannot connect. That is the uh, how the leaf and spine architecture design is. And why we cannot connect? Because of the full mesh loop prevention. So if we connect to leaf and spine to spine, there is a potential uh, issue, like it can create the loop within within the data center, within the infrastructure of ACI, right? So in order to avoid that, this is the plain architecture. We cannot connect leaf to leaf, spine to spine, because unlike this is the SDN based architecture, unlike the legacy network where core to core, distribution to distribution you connect, and you create the high availability in the infrastructure, right? But this is totally unlikely. We are by default getting the high availability of the leaf and switches. So like if we have two switches, it is connecting to recommendation of the leaf and spine. There should be two spines switches, and minimum should be the two leaf switches. So by default, you are getting the high availability of your infrastructure for leaf and spine both. So you do not need to connect the interconnection. You do not need to establish the interconnector, right? So each, suppose you have one endpoint here, one endpoint, it will always go through the spine switches. Okay, so that's again advantage. That's so leaf and spine is architecture is everything is one half away, right? So in ACI, fourth question is, in ACI mode deployment, how many controller are recommended in layer 3 fabric? So recommendation by default, it depends based on the your how many sites you are deploying, how many ports, how many uh, what kind of ACI architecture you are choosing, right? It can be single port, it can be a dual port, it, a dual port in the sense a dual fabric. Okay, and it can be your multi-site, it can be your multi-port. Okay, so by default, minimum cluster we Cisco recommend is 3. So there should be minimum 3 EPIC, and if you have the there is a limitation of 3 EPIC also. So 3 EPIC nodes can have up to like 200 leaf switches, right? If you have fabric and distributed across the two sites and it has more than 2 or 300 leaf switches, in that case, so it can be extended to 5 nodes, 7 nodes, 9 nodes. So APIC cluster always will be in odd mode, odd number, not in even number, right? So you cannot go with the 2 APIC cluster, 4 APIC cluster, 6 APIC cluster, 7 APIC, or 8 APIC cluster, right? It has to be in odd number, like 3 plus 5 plus 7 plus 9. So there is a concept which Cisco has introduced, standby APIC, which can be like 3 plus 1. So 1 will be always in standby, 3 will be active. Okay, so always by default recommendation is 3 minimum, bare minimum, and based on your fabric and the site size, you can enhance or increase the number of the APIC controllers. Fifth question is, in ACI mode, layer deployment, layer 2, layer 3 fabric, how many leaf and spine switches can be deployed? So again, so by default there is a 6 per port. We can have the 6 spine, okay, and 200 plus leaf, okay, can be deployed per port. And if you have a multi-site kind of, so it can be up to 6 site, sorry, 6 to 12 site ACI can be extended. If you have like 6 to 12 site, you can combine, you can configure the multi-site. So that is the another limitation of the ACI. Okay, and what benefit can be ripped out of Nexus ACI compared to traditional network solution? So what benefit we are getting? We can get that. Just give me a second. Let me show you something PDF. I have made very beautiful PDF on that. Just all right. So this is the few advantages which is there, like ACI versus legacy network. So this is a physical installation console for each network. So by default, ACI discover all the leaf and span if you connect one device to another, and it has the auto discovery protocols by default. And for management port, all the management configuration you can done through the one centralized application controller. If you have 200 devices, leaf and switches, you do not need to go individually log in each devices. You can everything can be done through the APIC controller itself. So it has single plane of the management, you can see. For software upgrade, you have to do in legacy one by one. Like if you have like 10 devices, you have to go one by one and do the upgrade for that. But in ACI we have different concept, so everything can be done in one click through the APIC controller and in the large scale. And you can also do the automation for the everything in ACI. So ACI has 3 interface. Okay, one is API, one is API interface, sorry. One is API, second is the northbound interface, and third is the southbound interface. Okay, so if we architecture is this one, okay, spine. So spine, this is the southbound, this is the northbound, and for leaf, this is the northbound, this is the southbound, and for the epic, APIC, this is the southbound and this is the northbound API interface. Okay. And if you talk about the application centric, so ACI is the application. ACI does support application centric as well as the network centric, both the deployments. By default, Lexi network only supports the network centric deployment. And in terms of the provisioning the new infrastructure, and if you have the like data center with the couple of the requirement, like tens of or 20 or 50 devices you have to install, it is time consuming, and where ACI can be deployed within like 1 day or 2 days in a period. And in operation, this is the simplex simplifies your operation, day-to-day operation, as well as in the infrastructure. Like we have the APIC controller here, single plane of the control. It can simplify your operation as well. And scalability, there is definitely hardware upgrade you have to do in every uh, a few years, and every if you like to scale up your infrastructure. But in wherever in the ACI we have only one concept, like if you by default ACI has huge scalability, but if you want to have the more scalability in the infrastructure, you can add more spines in the infrastructure and you will have the scalability. Okay, this is the fifth question answer. And if you go for sixth number question, so okay, so what is the role of APIC controller in the SCI fabric? Okay, so APIC controller just act as a policy manager. Okay, application policy manager. It is not the data plane. It is not the control plane. It is not the management plane. It can act management plane, but if suppose you have devices, right, and by default you have one AP, and this AP goes down, in that case you will not have any impact in the leaf and spine data plane and control plane. That's why we call it just a policy controller. Okay, and does AP control perform data traffic forwarding? No, it can control only policy, but it has nothing to do it has nothing to do with the data plane or control plane traffic. Okay, and the next question is what happen when all APIC controllers in the fabric goes down? It won't happen anything. So control plane and data plane will be still operational. Okay, but eventually if you like to configure the AP is your ACI, you have to bring the APIC controller up. Without APIC controller, you cannot configure ACI. That's a simple thing. That's only one disadvantage will be if APIC controller will be down. Okay, and the next question is sorry. The next question is, can we connect APIC directly to spine switches? Answer is no. We cannot connect APIC to spine switches because by default LDP protocols run between the APIC and the leaf switches, and there is a DSCP process also run between the APIC and leaf switches, which help to discover the your ACI infrastructure. And next question is that customer has new server and want to bundle the port from 3 node into one BPC. Can the ACI setup support? No, by default answer is no. Only the two maximum BPC member can be 2, not more than 2. Okay, that's the reason you cannot connect you cannot bind the 3 interface with a different leaf under the BPC policy. Okay, and the next question is, once the fabric is up, can endpoint communicate with each other? Why or why not? Okay, so there is two answer for this. So by default is suppose sorry. Okay, so if you have suppose leaf and spine, okay, spine, leaf, 1, 2, and there is a AP. Okay, suppose you have endpoint 1, endpoint 2, and by default if they want to communicate, definitely they can communicate by default. You do not need to do anything. but you have except the policy creation for interface and EPG creation. Okay, but in case you have the external communication like internet without the route reflector configuration on the spine switches, you cannot communicate from EPG to external. So internal to internal, that's the intra communication. So definitely answer is intra communication can be done, but for external communication, it cannot be done. Answer for this, because you need some kind of client who should take care about the external communication. That is something RR, route reflector. Okay. And the second next question is, what is the bridge domain in the ACI fab? Bridge domain is the L2 or L3 boundary in the ACI. So suppose you have the one in the point, right? In the point, and you need some gateway to communicate, right? The bridge domain can be act as any class gateway for your endpoint. So it's kind of L2, L3 boundaries. So it can be L2 and it can be L3. So if you want to have the L2 network, this domain will not have any kind of gateway. If you want to have the L3 network, you must configure the L3 gateway for on this domain. So it's kind of L2, L3 boundaries for the endpoints. So how is the bridge domain different from the VLAN? So VLAN is L2, only L2 segment, and bridge domain can have the more control over the traffic. So there is no comparison as such, but there is a few points where bridge domain is the superior than the VLAN. Like the bridge domain can have the policy, it can control the L2 and L3 traffic, it can have the a multicast traffic control, and it can have the multiple various feature which can be control the traffic, unlike the VLAN. VLAN is just the L2 segment, right? And what is the endpoint group, EPGs? So endpoint group is a collection of physical and virtual servers or IP address or kind of VMs. So suppose you have one server sitting here, right? It can be in one cluster. So one IP equal to one VLAN for ACI, one VLAN equal to, or one IP or MAC equal to one endpoint. Okay, we configure that. So endpoint is collection of physical and virtual devices, you can say. Explain the terms of tenant. Tenant is the uh, logical boundary. Logical boundary. So suppose you have the very big infrastructure, okay, and it you have three customer. One is the ISP, second is a service provider, and third is a production, right? And you do not want them to interconnect by default. Okay, you want to set kind of restriction on that. Or the requirement of the customer is I need separate infrastructure, and says what also said, I need separate infrastructure, I cannot share my infrastructure. In that case, if you are going ahead with and deploying the infrastructure for each requirement, you messed up in the budget part, right? So to avoid that kind of conflict, we have something called a tenant. It means it creates the logical boundaries, and it segregate your resource from the one to another customer here. And in one hardware, it can be 3-4 partition. So you can compare to VRF, but VRF is does not have that kind of control, but rather tenant has that kind of control. So you can say that one tenant is equal to one separate network. Okay, and define the terms of contract. Term of contract. So by default in ACI, everything is whitelisted. Okay, so nothing will be communicating by default in ACI, unlike the network in the legacy. By default, if you have the same VLAN, it can communicate to the L2, right? But if you put the VLAN 10 here and VLAN 10 here, by default, it will not allow any traffic. Whitelist or drop everything here, ASIC level. So in terms of the make the communication, you have to make the one access policy ACM. That is, we call it the contract here. Yeah? Okay, so contact has the control over L3. It cannot, or L4 sometime port level, but it cannot exceed more than that. Okay. And the next question, which uh, can I have the same VRF number in different tenant? Of course, yes, you can have that. And sorry, I missed that. What is the taboo contact? Taboo contact is something in order to block everything in your, suppose you want to configure by default deny any, right, in the ACL. So that is the call, deny any is the taboo contact. You have to be very specific to allow anything, right? And next question is, can an EPG point towards the more than one bridge domain? No, it cannot. And why it cannot? I can give you the answer for that. Just give me a second. It cannot. So there is a policy. So one bridge domain can be with the multiple EPG, but one EPG can not be with the multiple bridge domain. That is the how the ACI is designed. So we call that logical legend stuff. Oh, yeah. So you can note that. So EPG cannot be associated with more than one bridge domain, and bridge domain can be associated with the more than one EPGs. Okay. I define the application network policy. So application network policy, again, it comes under the access policy, where you have to define the domain policy, or a physical domain, logical domain, VLAN, or interface profile, or interface group profile, or node profile. Everything come under the access policy, and that is something we control through the APIC controller, and that is the policy which apply into the control plane and data plane through the APIC controller. Okay. And ACI fabric can have many types of EPG. How many types of EPG ACI can support? Okay. So there are multiple types of EPGs. So like first is the standard. Second is micro EPG or micro segmentation, you can say that. Okay. There's two types of EPG which can be by default support. So by default, whatever you're creating is come under the standard EPG. And if you want to be more specific or something like that, you have to control micro segmentation EPG. Okay, so there's two types of EPG by default. And can EPG points toward more than one bridge domain? No. EP, there is suppose EPG. EPG can associate only with the one bridge domain. I suppose bridge domain. It can associate with the multiple EPG. Okay. It's kind of a bridge domain to suppose EPG. So bridge domain to EPG like N1, suppose EPG to bridge domain 1, 1, something like that. Okay. So the next question is, can we apply policy to individual endpoints? Yes, you can apply that, especially when you're using the micro or micro EPGs. What is the concept of the micro-segmentation in ACI? So in the micro-segmentation, just like a private VLAN. So it is more than private VLAN, but the concept is very much same as a private VLAN in the legacy network. Like same VLAN, you do not want to, or even same subnet, you do not want to interact. And there is a requirement like you have only one server where you have multiple machines, and those machines are in the same segment, but for different use cases. You do not want to connect or interact with them, right, due to some limitation. In that case, you can implement the micro segmentation EPGs. And the next question is, what is need to have more than one EPG in the same VRF? That is the bridge domain. When you deploy the application-centric infrastructure, in that case, in the application infrastructure, you deploy 1-to-1 ratio, right? 1-to-1, one EPG to one bridge domain. And that is also to simplify your the configuration. Suppose you have the web, so you can create the web EPG and web bridge domain. Suppose you have the app EPG and app based domain. So one-to-one mapping. So in that case, your day-to-day operation will be easy, and you are just simplifying your network configuration, right? And what are the three default tenant which by default present here? So then is management, second is common, default. Okay, so management is only for the management perspective. You can use definitely for data traffic. Common tenant means whatever you are configuring the policy, it can share with the non-default tenant. And default is your normal standard tenant, okay, or infra tenant you can say rather. And illustrate the role of the VXLAN. So VXLAN act as a data plane, and which provides your encapsulation, decapsulation to your traffic, endpoint traffic in the ACI, within the ACI fabric. Okay, and what is the private network? How it is related to the VRF? So in the VRF label, there is two options: public and private. If you are creating the private, it will within the VR, within the tenant, it can communicate. If you are setting the public, it means across the multiple tenant, it can extend. Okay. And explain the next question is explain the terms of L3 out and why it required. So why require L3 out? So L3 out is for the external communication. Suppose you have one in the point or one host sitting here and they want to access the internet, right? In that case, you have to configure the L3 out in order to make that. And L3 out can run that routing protocol. Okay, like BGP, OSPF, EIGRP, RIP is not supported in the protocols. And static route, something like that. Okay. And the next question is which routing protocol run for internal communication between leaf and spine? So between leaf and spine, we have IS plus MBGP plus VXLAN plus scoop. These are the four protocols which run between the leaf and spine. Okay, and there is a different use cases of these protocols. Okay, the next question is in the ACI fabric, which node is configured as a route refactor, and why is need to configure route refactor? So spine's node we will configure the route refactor, and why in fact need a route refactor to avoid the full mesh setup in the infrastructure, avoid the overhead of the network, and avoid the uh, uh, any kind of a failure or single point of failure in the network. So if you have a route refactor, it can act as a bridge for your source and destination. So you do not need to flood your traffic by default to everywhere. You just know that this is the source, this is the destination. Okay, I have to go to this particular device. This device will know that everything whatever I required, right? So that's the major advantage. And it also is provide the scalability in the infrastructure, right? And the which Cisco Nexus 9K model are using the spine switches. So there is two types of Nexus 9K, 9300, which is we call that baby spine, 9300. Second is 9500. Okay, so 9300 is fixed chassis, 9500 is the modular chassis. And this is again 9200 also, but 9200 no one use. 9300, 9500, 9700 now it can be used. And can we connect a layer 3 device to spine switches? Yes, that is goal concept in ACI. So next question is, can we connect access layer switch in the downlink to layer switches? Yes, you can connect the access switch, access layers. You can connect access layer switch or trunk layer switch, whatever you like to connect from the ACI layer switches. What is the difference between multi-port and multi-site here? So so if you have the India, okay, and you have the Bangalore, you have the Mumbai, and you are deploying data center. Within the region, you having two availability zone. So in the same region, just like the AWS concept. Region, we have two availability zones, zone 1, zone 2. And in order to make the communication between them, we call this concept of the multi-port here. It means same cluster node is controlling your both the data center. It means single plane of the glass, single plane of the control plane, or single plane of the management of policy control. It means same cluster is controlling both the DC. You do not need to deploy separate cluster for each DC. Unlike the multi-site is combination when you have the it is multi-region, region 1, region 2. Suppose we have India, we have UK, right? And one DC is deployed here, one DC is deployed here. And you have individual separate cluster for each DC. And okay, and in order to deploy that DC, we have multi-site orchestrator, MSO. It means you have to purchase separate cluster as well as another set of separate cluster which provides you the single glass of plane for the your policy control. Okay, so this suppose we have, and for that we configure that, and we also do that, we call that multi-site concept here. So we configure the L3 devices here. So between the sites we have MBGP plus VXLAN internal. Okay. And the next question is, can the ACI leaf port be used for both spine connectivity upper and endpoint? No, it cannot. So leaf has two port uplink, that is northbound interface and southbound interface. So ACI, when you purchase the leaf, there is separate set of 4, 5 ports, 6 port by default. It means maximum 6 spine switches can be connected to per leaf. So 6 spine switches will have separate 40 gig port. Okay, it can be 1 gig, 2 gig, or 10 gig for the southbound interface, but by default, minimum requirement between the leaf and spine is 40 gig, or maximum can be 100 gig per interface. So it cannot be connected. Okay, and this question is, I have trunk port configured in one EPG, and can the access port also be added in the same EPG? Of course, yes, it can be added. Okay. And next question is, I have non-Cisco devices, checkpoint, and want to integrate the checkpoint management to Cisco APIC. Can third-party management be performed APIC controller? Yes, it can be done. So there is a separate set of plugin, manage and manage more. So you can integrate the non-Cisco checkpoint through the manage mode. It means APIC will control your checkpoint in the fabric. But for that, you need to have the separate plugin for that, which you can upload in the APIC itself. The next question is, what are the options available to manage configured API? Okay, so there is a multiple CLI, GUI interface, and API interface. So major three interface which we usually use. We usually prefer to use GUI interface and API interface for programming. Okay. The next question is, during initial setup, in case console cable is connected, voice hyperterm is not available, is there any other option which can be accessed? Yes, there is a CMC. If SSH is not available during this configuration. And what are two types of table found in Leaf? So first is local station table, and second is a global station table. Global also called the remote table. Okay, and third I would say is a proxy table, which usually spine maintain, but sometime also Leaf update in the local table. So there is two major: local table and global table, in this sense, low remote table, which also combine the proxy table. Okay, what is the concept of the shared? Shared means common tenant. Okay, so whatever you're creating the policy, it can be shared across the non-default tenants. That is part of the shared, and there is a different concept in shared also. In the shared mode means APIC shared, if you're talking about. So if you have three APIC, right? APIC 1, 2, 3, and if you're configuring any policy, right? So if layer 3 policy will be deployed through this APIC, and EPG policy will be deployed through this APIC, and your biz domain policy will be deployed through this APIC. So it's kind of shared replica of this one. So one will be, so suppose if you deployed L3 policy, this APIC 1, so APIC 2 and 3 will be follower for the layer 3 policy, and this will be the leader. And for the endpoint, this will be the leader, and this will be the followers and followers. For the bridge domain, this will be the leader, and this will be the followers and followers. Okay. And what is the pod and multi-pod? Pod means single location, single epic cluster. Multi-pod means it has in deployed in multiple zone, right, in the same region. Okay, so there are multiple questions. There are a few. Okay, so how ARP and broadcast handled by the ACI? So by default, ACI deny everything, and it enable the by default hardware proxy. So whenever any ARP request is going, it's not kind of flooding by default flooding entire the nodes. It has the proxy ARP mechanism which control your broadcasting in the ACI, and that's something you can configure under the British domain. Okay. So why and when you require contact in ACI in order to make the two endpoint or external or internal communication? Okay. How the unicast routing works. So it's a simple plain answer for this. So using the routing table, shortest path select, and unicast routing is based on the internal protocol also. So in ACI by default, we have ISIS, VXLAN, and PBTP, which by default find the shortest path for the unicast routing. Okay, and through the route vector. In Fabric, which switch will act as a default gateway for the particular subnet? So there is no particular one switch will act as a default gateway, but rather I would say in this domain will act as a default gateway, right? So suppose you have this domain call created, and you have endpoint which are deployed across the 10 switches, right? So this domain will sit in across the 10 switches. It's not like switch one will be as a default gateway for all the traffic. No, that's the beauty of the ACI, right? So next question is how Cisco define layer 2 traffic and layer 3 traffic. So layer 2 traffic through the bridge domain. If your bridge domain is the L2 flooding, it will be L2 traffic. If this domain is L3, it's going to be L3 traffic. How VLAN works in ACI. So there is no concept of the VLAN in ACI. Okay, so there is the concept of the VXLAN. So if I explain that, you have one endpoint, right? VLAN 10, one endpoint. So the moment VLAN 10 hit here, so there is a convergence happen. VLAN to PI VLAN, which is the hardware VLAN, and to VTAG, which is the VXLAN. So NIC label itself, the moment your traffic is hitting here, it will reflect as a like hardware, for example, like VLAN 20, and VTAG going to be changed, and it will form the tunnel between the leaf switches for communication. Okay, so VLAN will not reflect within the ACI. Why? Because of the limitation. VLAN has like, if same leaf is using 10 VLAN 20 or 10 VLAN 10 VLAN 10 for the 20 ports, right? And if VLAN 10 is allowed in the database or table, it will conflict your ACI, right? Or conflict your database. So that's the reason it automatically convert your into the PI VLAN, hardware VLAN. Okay, so okay. This is most of can we configure the access and trunk port? Of course, you can do that. But the micro-segmentation, again, I have already explained that. And how to configure inter-VLAN, inter-VRF and inter-tenant communication. So there is a concept in the L3 out or contract import. Through the import and export, you can configure the inter-tenant communication, establish the inter-tenant communication, inter-VRF communication. You have to create the VRF leaking policy if you had the L3 out kind of. And but for that inter-tenant communication, you have to import and export the contract between the tenants. How can you integrate Cisco SCI with the VMware? So there is a VMM domain which you can directly integrate or configure through the ACI APIC policy. And by default, it controlled through the BDS or DBS switch. So by default, when you integrate your VMware EXXI vCenter with the APIC, APIC will push their VDS switch on the EXXI vCenter, and where you associate your endpoint based on the EPG which we create through the APIC. Next question is explain about the ACI fabric policy. So ACI, there is two policy in ACI, access policy and fabric policy. Okay. So for the access port, like for southbound interface, whatever policy is creating for endpoints, this is the access policy. Whatever policy we are changing and creating between leaf and spine, that is the fabric policy. Okay. And the question is fabric discovery process. So fabric discovery process, the moment you connect your APIC, so if you have APIC, so APIC will send the LLDP. Okay. And by default, when we set up the APIC, we configure that tap address, right? So once the discoveries happen, this will send your discovery. Then switch will say, okay, give me the IP address. It's kind of DORA process. If you know the DSCP DORA process, discovery, offer, request, acknowledgement. This has happened for this one. And once the leaf one is discovered, then it will go for the spine discovery. Then once the spine discovery is done, then it will go for the leaf discovery again. This is how the discovery happens. I'm not going into the deep because it may take a lot of time for me to explain that process. But definitely there is a document, or there is I think a post which you can find in my LinkedIn post for the DORA process. Explain about the traffic flow lookup in the ACI. So again, this is huge topic, and I like you can go to my channel. To be honest, you can search like technology expert, technology expert. In the technology expert, you can find like end-to-end flow. Look here. So in this high level flow, you can all the in the point label or troubleshooting label, how to troubleshoot, everything is I have explained in this session, and which is very much used cases. Like if you see the discovery process here, right? So how the LLDP works here, and how the DSCP works, how the LLCP ISS work, how the certification works, and what is the DME, and what is the VXLAN tunnel build. So each and every, and how to troubleshoot, and how to check in the ACI fabric, right? So all the things is already been updated here. You can go and check here in my channel. Channel name is Technology Expert. Okay, and here this video also I am going to update this video also. So yeah, hope you question is clear. Okay, so this was the last question. Yeah, and this is just a tenant, like we have infra tenant and the management tenant and common tenant. There's three tenants, and there are, I have attached a few questions. So in the next, like if you like to check the troubleshooting part again, please visit to my channel, and here you will find each and every. I have uploaded very few videos due to the time issue, and how to set up the APIC and CIMC, all the things with SD-WAN. In the coming uh, months or week, I'm going to update the session or videos with the new technology like the Kubernetes or Versa SD-WAN, Aruba switches, all the things is in pipeline, including the security architecture in the information security related questions as well. Yep, thanks for watching the session, and we'll see you soon.